people have requested like range types or regex types or all these other kinds of types, and ArkType has those things in its type system already. The benefit is really exciting that like it can give you such deep information about the way types relate to each other. It can optimize your types in ways that no other validator could based on that understanding. It can give you really good error messages. You'll just see if you use ArkType, like the more you get into like the way the types are automatically simplified and stuff, like this idea of like everything has one representation and anything you define that's redundant is sort of like merged into the core type. The way it is in TypeScript, right? If you say string and this string literal, it will just reduce to the string literal, just based on how the set theory works. Like that's true here too, but in a much more thorough way.
Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Eric Onerheim. Together, we're the two TypeScript fools. Welcome to the show.
Hello. Welcome to the show. It's TypeScript FM. We have David Blass here, author of ArkType. Hey, David Blass, can you give yourself a little intro?
Yeah, of course. So my name is David. Been working on open source full time for 4 or 5 years now in the TypeScript ecosystem. I've had a ton of fun getting to work on a really cool project called ArkType, that the goal of which is to bring TypeScript to runtime and kind of give you the same power and expressiveness that TypeScript offers within your editor, but then make it available at runtime as well, which I think for a lot of TypeScript developers has always kind of been this fantasy of, could I use my types at runtime? And, technically no, but we're trying to get as close as is possible within the confines of JavaScript as a language and bring not only as many of the features from a type inference perspective to kind of bridge that gap, but also even bring some of TypeScript's cooler features around being able to compare types to one another and analyze things based on set theory. So really trying to bring a full-fledged TypeScript type system to JavaScript. So really cool project to work on, and I'm very excited to be here talking about it with you guys. Yeah,
sounds good. And we've mentioned ArkType probably a dozen times over the course of the podcast, but neither of us are,
a lot of mentions.
Neither of us are experts in it. We haven't really used it in production. I think probably a good place to start is where we are familiar with, which is what? Zod for creating validation schemas and doing runtime validation. So that might be kind of a nice anchor point for the audience. They might be already familiar with Zod, but they've probably heard about ArkType. How would you sort of introduce ArkType as compared to Zod?
Yeah, so Zod is a great library, and Colin is actually a good friend of mine, and we have a lot of mutual respect. So I think that Zod has obviously become a huge staple in the ecosystem, and for good reason. It's composable, it's easy to use, the type inference and the performance have gotten better with version 4 in particular. I would say ArkType is maybe you would say it's like a more ambitious project. It's kind of seeks to do more in terms of, again, like bringing really deep introspection capabilities, like serializable definitions. Obviously, the like bringing TypeScript syntax to runtime is a very different approach than most other validators, which isn't to say necessarily that it's inherently better, because I think complexity comes with a cost. And yeah, so there are things that are going to be a little bit trickier when you're trying to mirror TypeScript syntax one-to-one. But there's also huge advantages in terms of concision. I think definitions in ArkType are usually about half as long. It can kind of use a lot of that introspection capabilities to really optimize your types and get validation to be very fast. Zod has made some improvements in that area, but ArkType is still going to be considerably faster for pure validation. And then there's been a lot of optimization around things like error messages. So you get out of the box these like really carefully kind of crafted union errors where it'll try to, collapse down branches and give a very concise statement of all the things that went wrong. So there's been optimizations in some of these various areas, but probably the most unique things about ArkType compared to other validators that you're probably used to, just like right out of the gate. Obviously, the string syntax and the type-safe strings is pretty unique in general. There are a few other projects in the ecosystem that are starting to adopt these strategies, but it's going to look different than most APIs you've used for sure. There's flexibility there, but that's the core API, right? Like you can write TypeScript syntax, you put things in strings, and you get type level errors for that. So that's very different. And the other big thing is the runtime type system, which, like I said, is it's a little bit behind the scenes. So maybe we can delve into that a little bit more. It might not be the first thing that you're aware of when you're starting to use ArkType for the first time, but essentially the ability to say an ArkType like does one type extend another type, or all these kind of operations that you can do in TypeScript means you have to be able to ask questions that you can't ask with like a kind of a more standard schema AST library like Zod or Valibot or anything else that doesn't use this kind of like rigorous internal set theory based approach, which is super exciting. I think in particular, if there are listeners of the podcast who are working on libraries and like working on scenarios where they might want to like introspect types in a deeper way to make certain optimizations or to model certain relationships, that ability to determine the relationships between your types automatically and kind of have ArkType implicitly make optimizations around that, and then also expose a lot of those operations to you so you can, introspect and gather the information you need, is something that's really different from anything else out there. So yeah, I would say that there's definitely a lot of overlap between what ArkType can do and what Zod can do in terms of validation. But generally speaking, at least in terms of like the broad capabilities, I won't say that ArkType necessarily has a one-to-one match for keywords in Zod or anything, but usually I would say ArkType is sort of like a superset of the functionality that Zod covers just because of the internal type system and some of those other features.
Yeah, I think a great place to start is something you said at the beginning, which is that you use a stringly typed sort of syntax to create schemas. So listeners, if you imagine for Zod, you import, the Zod API and you do like z.string dot, whatever kind of validation you want, like .min. But with ArkType, one of the awesome things I was going through the tutorial, you say right up front, if you know TypeScript syntax, you already know the majority of ArkType syntax. So you define your schema the same way with like an object literal, but instead of using like a chained API, like a fluent chain API, you just do a string type, and the string, inside the string, you're just basically writing TypeScript syntax. So do you want to start with that, like how you actually sort of define those schemas and what that looks like?
Yeah, so that's definitely the most obvious thing when you're starting to use the library, you're like, this is different. It all evolved from this question that I had when I started work on ArkType a few years ago. That was, what's the closest within the confines of JavaScript that I can get to a one-to-one with TypeScript native type syntax? And I went through some iterations on it, but in the end, like if you really want the one-to-one, there's actually basically two. So one would be what I did, which I'll talk a little bit about. Another would be like fully string embed everything. So like you start writing type, and then you'd put the object literal and all the nested objects, and everything you do would be inside of a string. And then it would truly be one-to-one, but there are some major trade-offs there. So I thought about that stuff. I thought, okay, so I can get like a pure one-to-one with TypeScript, but for people who don't have like an extension installed to do formatting and stuff like this, it's going to be really gross to have like a massive string that you're writing everything in, even if it's a pure one-to-one. It's going to be a lot less efficient from a type perspective, because even though we've worked really hard to optimize the type level parser, I mean, you're parsing a huge amount more characters at once if you're embedding all of your objects and structures into the string itself. So I gave up on the idea of doing a pure one-to-one because I think I want it to be a great experience whether or not a developer there's an ArkType extension that adds highlighting, and it doesn't need to do formatting because it's short enough that usually those strings don't necessarily need to be automatically formatted, maybe in the future, but you shouldn't have to have that to have a really great DX. And I think the only way that was going to happen is if it's a little bit of a combination of you use the native structures in JS, like object literals and tuple literals that match what TypeScript carried over. TypeScript types also have object literals and tuple literals. But when you're defining the kind of like leaf level values, you would define those in strings. And those strings can include arbitrary TypeScript syntax with arrays or parentheses or unions and intersections, and it all works the same way that it would work in TypeScript. But it is technically, so that's like the primary API. And if you look at it, it does end up looking very, very close to a one-to-one with TypeScript, where you have, type and then name, key, and then you have the string, maybe it's string or something like that. But you can write any expression there, and it gives you autocomplete, and it gives you type errors. It feels very much like you're editing almost like a native type because of how much type information there is. So it's a very different sort of API there. But kind of low key, or like we try to talk about it a little bit, but we do support other types of APIs as well, because like that approach works great in lots of scenarios. But there are scenarios where, like, if you're wanting to add custom metadata as you define a regex type or something, you actually probably want to do some kind of like chaining so you can pass all those things together. It's just not a neat thing to like try to string embed something like that. So we do actually have like a fluent API equivalent of everything that you can do with string syntax. And there's even a couple other ways you can try to combine syntax elements together that just makes it so that you can basically choose the right tool for the job. And if you check out the ArkType documentation, you'll see that like all the expression docs, you can kind of click on which tab you want between the string API and the fluent API. And then again, there's a couple other ways that are sort of optimal for different scenarios. But basically the goal is just to be really flexible and composable, kind of like the way you think about Zod. You can do the same stuff where you like pass a type as a key of another type or as a value in another type, and all that like composition and referencing stuff works fine, but it just has this added capability of like for the scenarios, for the 80 or 90% of scenarios where it's a good fit to do the one-to-one string syntax that really matches TypeScript, you're going to have that available. And I think there's a ton of benefits to that kind of approach where it does fit well.
Yeah, the DX.
Yeah, you're doing a lot of type theory stuff here. Like, how do you like reckon that? It feels like you're maybe even approaching like re-implementing TypeScript. Is that what it feels like sometimes?
Well, yeah. I mean, I think that there are parts of ArkType that is I've had to solve some of the same problems that TypeScript had to solve, but I had a lot of benefits. So first of all, TypeScript, a huge amount of it is like dealing with random legacy JavaScript stuff that, I don't have to worry about. Basically, everything to do with static analysis, like looking at control flow and figuring out what the value of some variable is at some point in an if statement or whatever. How does this expression change the value, narrowing based on some discrimination or something? None of that stuff is relevant to what I'm doing. So it's like if you thought about TypeScript, but then you pared it down to only the parts of it that would be relevant if all you did was write type foo is an object that looks like this, and type bar is a string with this additional, branding or whatever that it is, right? So those parts of TypeScript are the parts that I did work on. And those parts of TypeScript are kind of beautiful, I would say. Like JavaScript is kind of messy, and TypeScript was built around JavaScript and evolved alongside it and has a lot of those sort of like warts and impurities that JavaScript has. As much as I love it, like that's just the reality of how it came about. But what TypeScript is based on is this like set theoretic type system. And a lot of those operations, as I started to learn about them, are really beautiful. And so luckily, I really mostly got to work within the confines of the kind of like pure mathematical set theory that underlies TypeScript and that helps you understand why TypeScript behaves the way it does and why something is assignable to another thing. There are definitely some interesting cases where TypeScript may not have gone the most precise route, even though in this area it is much more predictable than when it has to deal with control flow and those other questions. But there are still a few cases where like I have to make decisions about where do I diverge from TypeScript's behavior and say, well, they really got it a little bit wrong here. So I'm going to do something that's not going to match that behavior one-to-one, but it's going to be more accurate, versus where is the compatibility problems that will create, where are those significant enough that they kind of like outweighs the benefit of being more correct. But I'll say that like the entire type system being built out in a lot of ways was kind of like I had the benefit of seeing how TypeScript worked and getting to know that pretty well, seeing what people didn't like about that, and kind of getting this like distilled understanding where I could implement it in a kind of like one shot in like a very, again, like a much more kind of like pure and precise way. Like everything's going to work based on these rules of set theory. There's not going to be any random exceptions because it makes transitioning from JavaScript easier or whatever. But like it does end up really closely mirroring TypeScript. But yeah, some of those differences in terms of like making trade-off between compatibility and correctness were very interesting forks in the road.
Yeah, that's awesome. I think the DX of ArkType is pretty fantastic because I was playing with the playground and I just love the one-to-one syntax. So when you hover over your type that you created with ArkType, it looks exactly like a TypeScript interface. So it's really easy to read. And I think another part of that DX that you mentioned is the errors that you get back. So do you want to talk a little bit maybe about what people can expect both from the compiler errors that they can get, and then also when they do validation, like how does validation work in ArkType?
Yeah. So it's a good question. There's two parts of it, just like you described.
Mhm.
So there's the errors that you get when you're creating a type and you make a mistake, maybe like referencing a name that doesn't exist or something like that. Because we have this like string syntax now, right? So there's a lot of errors that can occur when you're typing random syntactic expressions. And so one of the really cool things about that is that you don't just get like descriptive errors when you try to run your code and there is an error where you didn't close a parenthesis or something. You'll actually see in your editor, even if you don't have any extensions or anything, because it's done purely in TypeScript with a type level parser, you'll get these really detailed error messages about any mistakes you make. You know, maybe you typed, strang or something instead of string. I don't know. But you'd get a message like strang doesn't exist or something like that. Or yeah, again, if you don't close a parenthesis, it'll say missing closing parenthesis before these characters, and it will really like, and this is just the types in your editor. So it really helps guide you toward that stuff being correct. And a lot of people think like, well, there's no way that strings in TypeScript are going to be as safe as like native code. But it's really funny, maybe just because I'm really anal and I worked a long time on those errors. But like if you go in and you start trying to break that syntax and you see what kind of error messages you get and you compare it to the error messages you get natively in your editor, if you start deleting close parentheses or start deleting brackets or something, like they're better. They're definitely better. They're very tailored to like help you solve that problem right away. But it really feels, especially if you have the extension, which again is not required, but will kind of also do a little trick where it extracts out the little relevant bit of the error for you so you can see that right away in line. Like that stuff really makes it feel like it's a native quality, like you're not losing anything in terms of just writing the type directly in your editor versus this approach. Like you get really, really good autocomplete feedback that's really tailored to what you're doing and also really good type level errors. So I think that's a big, I would say it's like a selling point, but I would also say that if that wasn't the case, this would not work. I would not want to do this if I could easily make a typo and then I'd have to run my code to see that I typed strang instead of string or whatever, right? So like it's a selling point, but I do think for this like one-to-one arbitrary string syntax thing to be viable at all and for it to be something that I would want to use, it's kind of prerequisite, but it does work that way. So I think it all works out.
Well, I was mashing in the playground, and I will definitely say that the errors are extremely good. Like I was throwing some wild stuff at it, and it was very, very good.
There's a lot about how types are displayed and what type level error messages you get, what kind of autocomplete you get. So there was a ton of things that I had no way to test. So I ended up having to build a test framework called Attest that does this like type level testing. I would highly recommend if anyone has like test types, if they're working on any type level logic. I'm just like ArkType, you could say like, hey, there's Zod. Zod is a great library. Validbot is a great library. There's a few different really good solutions out there, but like there is literally nothing out there that covers most of those features. Like it didn't exist. I didn't want to build this. I didn't go in and say I want to build a type testing library or something. It just didn't exist, so I had to build it to be able to test ArkType. But most of those assertions that cover the errors you get in line as you're trying to define a type actually come in the form of, or all the tests around that use this assertion called throws and has type error. And so you can imagine like basically what it means is if I write a type that's like missing a parenthesis or something like that, I'll do this assertion, it'll do like attest, and then I'll write that type like within the call, and it'll be like dot throws and has type error. And then when I go and run the test, it'll check TypeScript's output for that particular line, and it will say, was there an error that matched this exact string? And also when you run the code at runtime, does it also give the identical matching error at runtime? Because that was the general principle, is it's like a pure one-to-one of like what you see when you're writing the types is identical to what you're going to get when you do the runtime, when you actually try to run it. And ideally you wouldn't, because you'd see the type error first. But if for whatever reason you do, we still want to throw an error at that point. So that's
got
what
the coworker that turned off TypeScript in their editor, you know?
Yeah, or maybe they're abusing, who knows what they're doing with their types, but maybe they've just crashed their TypeScript server. I've done some kind of like consulting around trying to optimize people's types, and you'd be shocked at the horrors that exist out there. So sometimes the language server can't survive. So maybe there's some reason why people need to get the runtime error. The runtime errors are sometimes like a little bit of a superset of what you get. Almost anything like syntactically or even some of the stuff semantically, you'll still get type errors for. So like, for example, if you said Boolean less than 5, because there's like a less than, or there's like comparator operators in ArkType that work on numbers or strings or arrays. Strings or arrays are the length of that thing. But you couldn't say Boolean less than 5. And it's kind of like a very interesting problem because you have to be able to look at that part of the expression. And sure, if it's just Boolean, the keyword, maybe it's obvious. But more generally, like you have to do the sort of like full syntactic analysis. Maybe it's a union of things. And you say, does this union, are they all assignable to number or are they all assignable to string? And it can do all of that at a type level. So if you write Boolean less than 5, it will say, less than operator can only apply to a number, a string, or an array, or a date, I suppose, also. But yeah, so that it can all do at a type level. The only things you'll see that you will only get the errors at runtime are cases where you have like no overlap between two types that you intersect, or something that's like, we can tell because of our internal runtime type system that that's never going to work, but it would be impossible or impractical. There were some cases for practicality, for a performance perspective, that we decided to not give certain errors statically, even though almost anything is basically possible. I mean, we've seen the Doom types, right? So, you can pretty much you can pretty much do anything. But like some things you have to make pragmatic trade-offs about, like, is it worth it to do this analysis that's going to take a long time in order to give an error that 0.01% of people are going to see? So there's a couple things that we'll give as like additional runtime, but the principle is anytime we can give a type error, we want that to be one-to-one with what you see at runtime. And there's a lot of care and thought that gets put into, how those expressions are crafted so that you can see at a glance like exactly what's wrong, and it's hopefully pointing you in the right direction to be able to fix that.
Yeah, there was a really cool thing that I saw while I was playing around with ArkType, and that's this JIT-optimized code. How did you do that?
No, I mean, this is more like nightmare territory, to be honest. But so like I was like, I should make ArkType really fast, and there's been this strategy that has like emerged for optimizing these kind of functions to do with using new function and like basically creating the like writing the JavaScript code and instantiating like a new function with that source code. But basically the difference is that when you think about a loop, it's like looping over some arbitrary set of constraints to validate them or something like that. It's hard to analyze for V8, like what the exact guarantees are, like for one particular scenario. So you can't just like optimize the fast path the way that it can if you write a very specific function that says like, check this property, then check this property, then check this property. And you can reference all those properties by names. So what it uses is this strategy where it does it differently than like libraries like Typebox and Tipia. I don't know if it's Tipia or Typia, but either way, there have been other libraries that have used this approach. ArkType does it a bit differently, where I don't know, we haven't really talked about this concept of scopes in ArkType, but basically like everything in ArkType, all the keywords that are available are based on a scope that's called like the default scope or the kind of global scope that is available when you use the type function in ArkType. And so that's all of our built-in keywords. But you can create a scope and you can create something called my cool keyword or whatever. And then when you start typing in addition to those no built-in types to start with my, but like you'll get your autocomplete alongside the autocomplete of everything that's built in. And so the JIT optimizations actually use the same principle where when a scope is created, either based on like something with your own keywords or just based on some like one-off type that you have that leverages the built-in scope, it actually creates this object where all of the like internal types that exist within that scope are mapped to these functions that are written in this way where they aren't loops. They're not like referencing indices of an array. They're giving like specific property names and saying like, check this, check that. And then they all kind of call each other. And it turns out that the V8 and other engines can optimize that to be much faster than that would be possible with a standard approach. And I think Zod 4 has also used this strategy to some extent, not as like comprehensively as ArkType, but they used it for kind of like the lowest hanging fruit, which again, like I think that makes a ton of sense and is a very smart thing to do. So Zod 4 got a lot faster. It was like, I think ArkType was like 100 times faster than Zod 3, and it's like 20 times faster than Zod 4 for checking objects. So obviously Zod 4 got a lot faster. But it means that like if you look at the code for ArkType and you look at the type system, that there is for every type node, it is there. It has to be able to output like JavaScript code. So it's like literally returning this like string version of the logic that it represents. Yeah, I mean it's like a pre-compiled version of ArkType, right? So ArkType has 4 implementations of validation. It's like there is the dynamic version that's actually attached to each type node for checking whether or not as a Boolean one value is allowed by a type. Then there's the like dynamic version written inline, the real version for ArkType of the full traversal. So like not just is it allowed or not, but check to see what errors exist, because it's way faster. If you don't need to report the errors with like detailed error messages and you don't have to have context, it's a lot faster to just say yes or no. So we always check yes or no first. So if it's yes, it's really fast. If it's no, it's not going to be as fast because we want to build a good error message. And honestly, in the real world, I would say like, I bet you it's like 98% yes. Maybe not for forms, but like
Right.
for like doing JSON payload validation and stuff like that, like it's almost always going to be valid. So having the yes case be really fast is probably the most important thing, and having the no case give detailed error messages is probably also good.
I was looking at this
the,
code
like,
and I was like, yeah, the happy path looks like the monomorphic path. So it was like, I was like, oh, I bet you that's how you're doing it.
Yeah, exactly. And then there's the like JIT compiled like stringified version of the yes or no Boolean. It's called allows versus traverse, but like allows, and then the JIT compiled version of traverse. So there's already 4 different things, and I could add more paths, and I could say like, well, what if I'm going to transform it? Like, should I build it from scratch? You could keep adding on, but it's already 4 different times that validation is implemented, which was a pain. And I think I rely a lot on having like a lot of thorough tests to make sure that all these different things are working the way that they're supposed to. We support environments where like new function optimizations wouldn't be enabled. So like, and it used to be that in Cloudflare workers, for example, like you couldn't use new function. And so we'll automatically fall back to just like the standard dynamic unoptimized. It's still relatively fast, but like it's not going to be as fast, of course, if we can't use those strategies. And you can like disable JIT or whatever. So it's, I think now Cloudflare actually has an option that says allow new function for these reasons, because there are libraries like ArkType and now Zod that use this strategy to optimize. So I think you can enable it, but there may be other scenarios where you can't. And if you can, it will still work. So that's what I meant. It was always a first principle that like this should just work. It's just JavaScript. There's no dependencies. It should be totally fine and portable. So even with all the JIT compilation stuff, if you're running in an environment that doesn't support new function, then it will just silently fall back to the standard implementation, and it won't be quite as fast, but everything will work identically. So that should be fine as well.
This wasn't even a thing I considered as a problem when I thought about ArkType, but that is totally a problem. Like if you have this almost this editor time aspect to the API, and then you have the compile time aspect, or I guess the runtime aspect of the API. I'm treating it like it's compiling, but this runtime parsing impact, and you definitely want them to overlap as much as possible.
Yeah, that's right.
Part of this now is like, oh, how did you get that editor time thing so fast? Because that's like you're now doing like really critical like computation in the programmer loop. So like it's important that that's fast. How'd you do that?
Yeah, so I talked a little bit about attest, and I talked about the need for me to be able to test things at a type level like autocomplete and type errors. But probably the number one most important thing was I needed a way to measure performance of types. And so I iterated a bit on like what the best heuristics for that would be really granular, because you can measure check time, but it's not very good for one statement. You're not going to get good results. You're not going to be able to reliably compare from one, optimization to the next. Is this better or worse? And what I landed on was type instantiations as a really good heuristic for type performance. And you could also take a look at, there's like a metric that TypeScript will output called the number of types that were created. It's just called types. But I found instantiations to be a really good heuristic for like, if you're testing an individual expression, and what a test, I built benchmarking into it so that you write like a bench block and then you write whatever logic that includes types, or maybe it's just, function calls that end up creating types, but it will capture the number of type instantiations contributed by that specific block of code. And then you can optimize your types, or try to optimize your types and rerun it. And it runs really fast. You can write a series of benchmarks, and impressively, like, of course, it depends on how fast the type checking is for your project. But especially if it's like standalone types and you're just trying to see like, hey, is this version of some intersect merge objects more efficient, or is this one? Like, it'll run in a second, or maybe even faster once we can integrate it with TSGo. I don't know like what the actual availability of those APIs is going to be and when we'll be able to dig into that stuff more from that perspective. But yeah, I mean, it's already very fast, and it just is such a great tool as we were working on the parser, because there's so many ways to do type level parsing inefficiently, and like those are the intuitive ways to do it probably. Like when I first was building it, it was very inefficient, and I thought there's no way this is ever going to scale and be viable. But I started optimizing it, and I started finding things to do that were more efficient, and it ended up being a very different approach than the one that would probably be the more intuitive thing, would be to do some kind of like top down, like, okay, look, is there a union operator there? And that wasn't going to work, not only because of the performance, but if I really wanted it to be one-to-one, like that has limitations in terms of the accuracy that you can get, because you don't know if you're like looking to see if a string has a pipe in it. Like you don't know if that pipe is part of a string literal or is something else, and you don't know about the ordering, you don't know about nested parentheses. Like that just has a very limited amount of precision that it can give you. So what it ended up being, and I was very pleasantly surprised to find that this was very efficient from a performance perspective also, was a shift reduce parser that iterates through one character at a time.
Oh.
And then decides what to do with that one character, but it's like fully left to right, and just like builds up basically like an AST, and has a state that it maintains at a type level as it's iterating over each character, and says like, what groups do we have on a stack? Like what, branches of a union do we have that we're currently parsing? And then that's how it'll create these really good type level errors. It will say like, okay, well, you just ended your string, but we still have one group left on our type level state stack. So like we know that you didn't close a parenthesis or things like that. So it's all based on that algorithm, which ended up being really efficient from a performance perspective as well, which I don't think anyone, including the TypeScript team, probably would have anticipated, because like no one knows this stuff, right? You just have to experiment with it and to try it out. And it turns out that this like character by character parsing is something that TypeScript is really efficient at. And so I mentioned that like the type level performance of Zod has definitely gotten better with V4, but ArkType is still very comparable and better in many scenarios if you like compare them one-to-one, which is crazy just based on what is happening when you are parsing an ArkType type. Like it's so much stuff that's happening, but the performance is at least as good in many cases as what Zod is doing, which is a more straightforward API. Not to say that that's inherently a bad thing. Sometimes straightforward APIs are straightforward for a reason, and they're good. But I will say that this was probably the biggest barrier I thought going into working on ArkType. And when I had the sort of vision for what the API I wanted would look like, I thought like there'll be a ceiling on the performance you can get that's going to be a problem eventually for larger projects, for like writing big schemas. And it turns out that not necessarily. I think that it's really very competitive, even in terms of that kind of ceiling for performance. So it's exciting.
I have a question here. Like, how do you even optimize types? Like, I don't even know what like a good type for TypeScript looks like. Like to me, it's completely black box, and this feels very arcane. Like you've got the secrets of the universe now.
Well, I don't know. It would be great if the optimizing TypeScript types would unlock the secrets of the universe. But I mean, it is a niche skill, 100%. That's why I've done like consulting around it. Is that it's hard to like build intuitions about a little bit, and most people just aren't writing the kind of types that you'd even think about optimizing. Most people are writing types to represent their data, and maybe they write a couple types that are transformations so they can derive other types from them. Like you think of like stuff like pick or omit. Maybe you need some kind of like custom versions of that do a little bit the stuff that's a little bit more tailored to what you're building. But that's different than writing a type level parser where that's like a non-trivial runtime problem, and you're solving it with types. And at that point, like you're not really thinking of types as like I'm modeling my data. You're thinking of types as this is a way to express arbitrary logic. And so at that point, your mental model is more like I'm writing functions. But there are differences, and the intuitions you have from runtime are probably not great when it comes to writing optimal types. So like the way I like to think about it is if you have all your functions are memoized, so like implicitly. So you don't have to explicitly cache anything you're doing, but if you pass the same parameters to a function multiple times, you'll never have to evaluate that type twice. That's a very important aspect of how TypeScript works and why it's performant at scale in many scenarios. So that like removes a lot of concerns in terms of like things that you do at runtime, like calling my expensive type twice or whatever in different branches. And, you'd think like, well, is this really inefficient? But it's really not a problem generally. But it means that the things that are that you do want to focus on is minimizing the context of what you're passing around from one type to the next so that you're hitting the cache as often as possible. So you think like at runtime, you might pass like a big context object with lots of stuff on it, and maybe you only use 3 things on that object. But that means that if there's 20 other things that have no impact on the computation result that you're trying to achieve, they're still going to prevent hitting the cache. And so you might be doing 20 times the amount of work or 100 times the amount of work, or who knows based on how those scenarios can evolve. But basically, like what it comes down to is writing these type level functions that have one really specific purpose, take in exactly what they need to be able to achieve that purpose granularly, and then return it. And then you're going to be taking as much advantage of the cache as possible. And you can probably guess that based on the type level parsing stuff I was describing, that like that's very good for caching parse results, because once you parse string or string array or string or number once, every other time you see that string right off the bat at the top level, it's not going to have to do anything. It's just going to say, I know how to infer string or number. It's string or number, and it's going to skip right to the end. So that's very beneficial for this kind of strategy where if you're defining hundreds of schemas of types, you're undoubtedly going to use the same types and same expressions multiple times. As a weird side effect of that, like probably don't add random amounts of white space between you can do that like in terms of the parsing. Like the parser doesn't care about white space, but if you're thinking about caching, you could be making it a little bit worse if you're like, here, let me use 2 spaces
Malicious
here
types.
and 1 space here. Yeah.
I'm gonna bring ArkType to its knees. Let's add a bunch of spaces randomly.
That actually brings up a good tip. Is it useful to, if you're doing like a union and you're doing that in multiple schemas and it's the same union, like let's say string and number, is it good to always just have it consistent, like string or number versus like number or string?
Yeah.
Okay.
So that would be better.
Cool.
Like, look, I mean, I never tell people to optimize around this stuff because like, it's kind of think about it like TypeScript, right? It's like, this will happen whether you know about what's going on or not, like a lot. And so, sure, you could say that if people are writing their unions in different orders, like maybe that's not the best thing anyway for other reasons, just in terms of consistency and readability and all that stuff. But also, yes, like you might make the caching a little bit worse. But broadly speaking, like the number of scenarios where you're going to hit the cache because you're repeating something directly compared to the number of scenarios where you're doing a permutation of an equivalent type because you've changed the order of something like a union, I think that it's pretty minuscule. Like, yes, I'm sure that will happen, but it's not significant enough for me to tell people, like, you should really be worrying about this, because it's my job essentially to, like, just make it work with what people are doing. Frankly, like, it's good enough. Like, I'm talking about this caching stuff, but when I'm talking about the type performance, I'm not basing that on the fact that it's really expensive to do the parsing up front. And then if you are caching the same parse result over and over, it's, efficient because it only had to do it once. Like, it's efficient anyway. So even if you're really trying to be malicious and you're adding a bunch of white space to make equivalent expression have to be parsed, and, sure, then it's also having to parse extra characters because of all the white space you add. Maybe that's not the most optimal thing for multiple reasons, but it's also not going to, like, really be a huge problem for ArkType. I mean, I've explicitly challenged people. I'm like, can you break the type level parser? I offered a Doom Types t-shirt, I think, to the winner if someone could break it, but no one found anything, which I was really disappointed in. That was before the playground existed, so maybe I could get more people to participate now by being like, just go in the browser and just start hacking away like you did and see if you can find something to break it. It's pretty robust at this point.
Yeah, hack yourself first.
I'm just curious, what is one of your favorite, maybe lesser used features of ArkType? Like, what have you added that makes you super excited that maybe you haven't seen in other libraries that you think people would greatly benefit from?
Okay. I don't want to say something that isn't documented because there are really cool APIs that I haven't documented yet, but then if people just hear it on the podcast, I mean, okay, maybe if you're writing objects and you want to transform them, check out the map method, which is kind of like mirroring map types in TypeScript. It's really powerful. It allows you to change keys, values, optionality. It's actually more powerful than TypeScript because if you think about like TypeScript, one thing that might be frustrating about map types is you cannot change the optionality of some keys of a map type directly. You have to like extract them and then intersect it back or whatever. But this is ArkType map API where you basically get this like type safe list of all the properties on your type. and you can write an expression that's like, if the property is my prop one or whatever, like make it optional, and you'll get back like a fully typed version of that type with all the correct inference and all the correct runtime behavior. So that's a pretty cool one that I still need to document. So don't ask me what documentation is, and I don't have it yet. But I'm going to document it really soon. I think it's just one of those things where it's like a really, really powerful API, and like there were at certain points at which like sometimes TypeScript has its own internal limitations of like what it can actually infer, not about performance, but just about like if you're writing a conditional type, like will it kind of correctly associate your conditional check with the output of this return type, so that you get the correct like optionality on your props and all this stuff. And there were some like weird things, and I'm like, do I want to tell everyone about this and then have them be like, why isn't it working in this case? And I'm like, sorry, like TypeScript, like if TypeScript doesn't infer the return type correctly, like there's nothing I can do about that. But I've tested it. I think I've done some kind of like tweaks for that recently, and it's really reliable if you use those kind of specific patterns where you're checking for a particular key and then making modifications based on key names. Like it really does work well. So I'd recommend checking that out. And then the one that I by far like think is my favorite, and it's probably more targeted towards library authors or people doing like a little bit more meta level stuff than just like the pure validation, is the like dot extends, or all the APIs that are to do with the actual like set based type system. So like you can use dot extends on any type, and it works the same way as the extends keyword when you're writing conditional types in TypeScript. So you can say like type A dot extends type B, or pass in the definition that you want to check. So you could say, does type A extend string, or does type A extend an object where every string key is, a number, like an index signature. And you can do any of that stuff, and you'll just get these results. And it really is like a very, very powerful, both like externally, if you're again wanting to like understand relationships between types. You could say like maybe you have a certain shape that like your API needs, and you want someone to be able to pass in an arbitrary schema, and you want to make sure that the schema is compatible with that shape or extends that shape. Maybe you add on additional stuff, but these are runtime constraints that TypeScript doesn't have a representation of. So it's not just working at a type level. It's like all the other constraints that ArkType can represent, like regex and, range constraints like less than or greater than, or divisibility constraints like must be divisible by 2 or whatever. Like those all fit into this set-based type system as well. And all of them work with this kind of like ability to do these set-based comparisons and determine the relationship between types. And we use all that stuff internally as well when we're optimizing your types. Automatically discriminating unions is a big feature of ArkType, that like when you define a union, it will automatically choose the most efficient keys to discriminate and to check first to determine which branch you're on without you having to do anything explicitly to discriminate it, using a lot of that like set-based theory. There's also the overlaps use case, which is another one that's like, if you're like a TypeScript nerd, you might know about the like array includes problem, where you don't really know what the type is that you should pass to array includes, because like it doesn't necessarily have to be like purely what's in the array. If you have an array of numbers and then you have a variable you're trying to compare to it that's a string or a number, well, that's not assignable to number, but they could overlap, right? So this is a case where like TypeScript, if they had like an overlaps keyword, that would be amazing. I feel like that would be something that'd be really powerful. It's a powerful part of set theory, the idea of like, is there any value that satisfies these two types? But that's also something that ArkType is very good at answering. There's an overlaps method. And you can see like, do these two things have anything in common? And that's another very useful question that you can ask and say like, hey, well, the user passed me this schema, but I know that I need this shape. Is it actually theoretically impossible to like satisfy both at the same time? And in many cases, you can like catch errors early. So there's lots of benefits. So like we're using it a lot internally, but I think there's a ton of opportunity externally for people as well who are wanting to like be able to model relationships between types or entities in a database or whatever they're doing to like leverage some of these things more. I think like one of the really cool things you can mess around with would be like tuple intersections. So if you think about like tuple types with they can have like leading or trailing variadic, like a dot to dot element, and they can have like leading or trailing fixed elements, and then they can also have optional elements. So there's basically like 4 parts of a tuple type, which would be like the leading prefix elements, the optional elements, then the variadic element, and then the postfix elements. And that's pretty complicated structure that TypeScript supports there for those. But TypeScript doesn't know how to intersect arrays. If you say like one tuple and another tuple, like TypeScript will just do some nonsense. It doesn't know. It like tries to do a property-based like intersection and like looks at all the array methods, and it doesn't work. But it's very possible to do that from like a set theory-based perspective to say like, what is the overlap between these tuples? You'll just see if you use ArkType, like the more you get into like the way the types are automatically simplified and stuff, like this idea of like everything has one representation and anything you define that's redundant is sort of like merged into the core type. The way it is in TypeScript, right? If you say like string or like this string literal, it will just reduce to string. Or if you say string and this string literal, it will just reduce to the string literal. Just based on how the set theory works, like it's going to remove redundant parts of what you're doing. And so that's true here too, but in a much more thorough way. And it's so fun to mess around with that stuff because, I mean, when do you think about like what's going to happen when you intersect two tuples? But it turns out to be this like really interesting problem that has these very complex results. And that's one where like that specific thing, I would be so happy if there were one person out there who was like, oh yeah, I was like merging tuples and like I needed a tuple that had both these, like had these trailing elements in this, and like I intersected them and it gave me the right type and it all worked exactly the way that I needed it to work and I didn't have to do anything. If one person out there does that, I will be so happy. But
Comment
really
below.
like the reason, the reason I implemented it was just because like when you have a type system based on these core principles, even if in that one case, it's like such a niche case that like probably no one will ever do that, or it will be very obscure, or it's just something that someone will mess around with because they heard me say this. It's like, it's the principle in general that I can say it is always true that the type will be reduced to its simplest representation, and we'll always be able to tell if one type is assignable to another and remove any redundant conditions and check your type as efficiently as possible. So like the value in being able to say that without any qualification, I think is high enough that it's worth going a little bit out of the way to implement some cases that end up probably being a little bit off the beaten path, we'll say.
It feels like you've fallen into one of the classic developer traps, you know, one of them being building a game engine, the other one being programming language design. You know, this kind of feels like that second one. You're kind of falling into programming language design by proxy.
ArkType is like a little bit on the border between, it's not a programming language, but like it has its own syntax. It's doing a lot of like very meta level stuff within JavaScript where like, yeah, I mean, you're embedding syntax in JavaScript, checking it at a type level. There was a lot of thought that kind of went into like how to mirror some of these structures and syntactic expressions that exist in TypeScript. And I mean, that stuff is a lot of the, like not all the concerns you'd have designing a programming language, but it's not just an API either. You know, again, like when I'm thinking about stuff like how do I want to represent ranges with mins or maxes, or how do I want to represent divisibility, which you can do with like, there's a divisibility operator. It's the, you know, modulo that you'd use normally, you know, like those kind of decisions are things that mirror very much like what you would think about when you're designing a programming language from a syntactic perspective. So like I got a little bit of a taste of that, and it's a fun problem space. But I'll say that like it turned out that all the stuff to do with writing the type level parser and all the stuff to do with like designing the syntax and getting all the type errors to be perfect was not as hard as doing the set theoretic type reduction and optimization stuff, that's the one that I kind of like really stumbled into, and I was like, oh, this is complicated. It was hard to like get it so that it could compare types accurately, reduce types accurately, but the benefit is really exciting that like it can give you such deep information about the way types relate to each other. It can optimize your types in ways that no other validator could based on that understanding. It can give you really good error messages, which is kind of like funny that we got back to there. But like, you know, again, if it can automatically discriminate unions for you and like pick out which branches you're most likely to be on and give you these like tailored messages about what went wrong on that particular branch, or say like, for example, like I said, when you create a type based on an intersection, maybe you're like merging two properties together. If you said like, you know, maybe you had age in one case that's like a number between 0 and 18, and in another case it was a number greater than 18, and you try to intersect those two things, it will say like this type is unsatisfiable because there's no number that is in the range of 0 to 18 and is in the range greater than 18. So like it has these very robust guarantees about not being able to create unsatisfiable types. All these things that's not possible. Even if you wanted to add that feature to Zod or something like that, you would have to rewrite the entire internal part of Zod to mirror like what ArkType does. So that was by far the hardest part of the project, even though the flashy stuff is like how you get to use the type level parser. And that stuff is very cool to work on as well. But like the underappreciated part that I hope that people who are really nerdy about this kind of stuff and like types and set theory and that kind of thing, like I want more people to experiment more with like the internal type system, because there was definitely a lot of work that went into that. And it's the kind of thing that library authors are the ones who are going to be able to make the most use of that, especially given like the serializable type syntax stuff, because I feel like that's another one where like you can't write a Zod definition in a JSON file, obviously.
Mm-hmm.
There's no Z dot in JSON, but
Mm-hmm.
like you can write an ArkType definition in a JSON file. You can't do everything, obviously, because ArkType supports custom validation functions and transformation logic and all that stuff that Zod supports also. But like there's a significant subset of ArkType that is purely like objects and strings, and it's a much more concise representation than something like JSON schema, and can even represent more stuff than JSON schema can represent. And so like that's a really exciting thing, that ArkType itself is not really going to be the one to kind of like solve the problem of like, how do I use this now? But having this like basically ability, like TypeScript syntax extended with runtime capabilities as well for regex and ranges and divisibility and all those sorts of things, be like fully serializable, and you can write it to JSON and read it from JSON, is like a really unique capability that I'm waiting for library authors to start to like pick up on and do cool stuff with it. I probably am not going to be the one to do those things, but I would love to talk with anyone who's interested in working with that stuff.
One thing that like percolated in my mind as you're talking about this type level like optimization and this type level like all these features that are available, maybe above and beyond like what TypeScript can do, given this relies on a lot of the code actually being run through a validator at runtime. But do you see any like features that could be backported into TypeScript, like things that TypeScript could be taking advantage of?
Oh, definitely. I mean, like I said, there's a lot of things that like ArkType was built in a much more pure set theory based way than TypeScript. And there's some aspects of that where TypeScript has decided to go in a direction, probably for compatibility reasons. I don't know if they would still do those things, but they kind of like violate those set theory based rules and lead to some of the holes in TypeScript that people don't like, the sound as holes. And I go in a different direction. I don't think they would not change that at this point, because it would create too many errors, too many breaking changes. But there are things that they could just improve the accuracy of. So like one of them would be, like I said, like array intersections, but they also could definitely take all the logic that I wrote for doing range intersections and divisibility intersections, and they could let people have types that said, I need a number greater than 0, and have that fully work with a type system that says a number greater than 0 is assignable to a number, but not assignable to a number greater than 10, right? Because of so it's like all those kind of like subtype relationships and things like that. And people have requested like range types or regex types or all these other kinds of types. And ArkType has those things in its type system already. So definitely, depending on like what TypeScript's level of enthusiasm is for adding these things, it's definitely possible.
So there is something that we've mentioned here on the podcast called standard schema. So listeners might have heard about this initiative, but do you want to give maybe a little bit of an overview, like what is standard schema and sort of what can people expect for the future of ArkType and the future of some of these other schema validator libraries?
Yeah, so standard schema is a really cool project that Colin from Zod and Fabian from Valibot and I have worked on over the last, I don't know, what has it been, like almost a year, probably, something like that. And it's basically just a spec that any schema or validation library can implement, so that when you need a schema in your API for another library, which lots of libraries need this, you think about things like TRBC would be like a classic example, but there are many libraries that say like, I need some way to know what the shape of your type is, and to use it to be able to check whether data is valid or not, and to be able to infer out what the TypeScript type associated with your data is. And in the past, those libraries have had to implement individually and say like, okay, if you want to pass a Zod schema or an ArkType type or whatever, like here are the libraries we support. But the ecosystem obviously is much better off if we can say, here's how you add a standard prop that has the types that we need and has the validation capabilities we need. And now anyone implementing a validator can immediately be supported by TRBC or any other library that wants to use this spec. It's a huge benefit to the ecosystem and encourages innovation. I think specifically that Colin deserves a huge shout out as being, like, I would say even the biggest sort of like impetus behind standard schema happening in the first place. He was kind of the one who initially like pushed it forward, and he has the most successful and widespread current schema library out there, and this certainly like opens the door more for other people to compete with him. So including ArkType and including Validbot, but also whoever else is out there building validation libraries. Like it makes the ecosystem much more open, because of course if you're like, well, I'm using this tool and this tool only supports Zod, that means you're probably going to use Zod. But now building a library, ideally, you should never have to do that anymore. You can accept standard schema, and then you can pass in any validator you want. So yeah, I think that Colin in particular deserves a lot of praise for spearheading that effort when it may be sort of counter in some sense to like the interests of Zod specifically continuing to have the level of dominance that it has. It opens things up more. It's obviously a fantastic library, so it can stand on its own merits, but like I just found it to be incredibly impressive and magnanimous of him, and I think it's a great thing for the ecosystem. So I'm excited to be continuing to work on it. I'll give a little sneak preview. I don't know exactly what we've publicized yet, but probably it's on a Git branch somewhere. So but we're actually working now on adding support to standard schema for a to JSON schema method.
Nice.
So a lot of people really have wanted that and have wanted the ability to have a standard schema way to say, how can I get JSON from this schema? And every ArkType type, for example, like has a to JSON schema method on it, but there's different rules for how you do that for different. Sometimes it's an external package for other validators and things like that. So now there'll be like one standardized way where you can access that, and every library will say, here's how you get the standard JSON schema source object. And that's especially important for AI and for using, because that generally tends to like, if it's generating data, we'll need to like introspect the structure and to use JSON schema. So this is a way that as AI is, becoming increasingly relevant, and that's like a very common workflow among developers to need a JSON schema for that reason. This kind of like opens the door again for more validators to be able to be accepted there, and to be able to hopefully we'll see if like AI SDK and all these other people will maybe be able to like accept standard schema source or a standard JSON schema source to fill that need as well.
This just feels like a better JSON schema. This is like JSON schema plus plus.
I would say that's optimistic. It's not actually solving the same problems as JSON schema. It's actually just a method, a way to write. There needs to be a method that says like, here's how you can interact with this schema to perform validation and to determine whether some data is valid or not. Here's how you extract out the type. So that gives you what you need to be able to check data and to infer the type of data, but it does not tell you anything about the structure of the type. And so now we're adding a to-JSON schema method, because if people want to introspect the structure of the type, or if you're an AI library that only accepts JSON schema and needs to use that in order to generate the data that you're asking for, then you need to be able to actually provide some kind of standard structured representation. The tricky thing is, it's not one way to like write JSON schema for a given structure. There can be many different ways. You can have intersections and unions and a lot of the same features as ArkType. One thing that ArkType does is like fully reduces those things. So it actually has quite a strict guarantee about what the structure would be if you try to introspect your type. Whereas like JSON schema, it's going to be a little bit more like the Wild West if you really need to access it, because you don't know out of the box whether you're going to get some intersection of like two parts of an object. And then like, what if you want to know how many properties it has? You'd have to like have the logic in there to kind of like parse it and analyze it. So that is tricky. But like basically if you're writing standard object shape types, or if you're using ArkType, which reduces everything fully, so you don't have to worry about this problem. But like if you're writing things that kind of represent basic shapes, or that can be kind of translated one-to-one to JSON schema without this kind of ambiguity or like difficulty analyzing it or parsing it, then you could then look at introspect the JSON schema output structure and say like, okay, maybe we want to generate a form from this, or like who knows, whatever it is. But like you need some way to actually look at what properties exist on the type to be able to do that. And yeah, so this is one of the areas where like ArkType really excels if you're using ArkType directly, is like that introspection capability and that ability to like fully reduce a type and ask questions about it and like get the properties and all that stuff. Like ArkType is really good at that, but it's much harder to solve in a general way where other libraries don't have that capability of like full reduction and guarantees about structure. But like, it's still a little bit like, we'll give you something that's valid JSON schema, but there were some tricky questions we iterated for a while, like how do we want to kind of define this method and what guarantee should it have? Because like what about versions and about
Mhm.
what the structure of the output should be, because this gets into a problem that where people have asked for this for a while, but the reason we were hesitant initially is like there are so many variables you could theoretically want to control when it says like, what should my JSON schema output for this type look like, or for this schema look like? So it is a little tricky in that regard. But I think having some kind of baseline solution will be a really exciting thing for the ecosystem. So hopefully we're
sure.
going to get that in people's hands soon.
Yeah, I don't know if you've been able to talk to the folks over at Quick, but I was just explaining in another episode, I just finished a Quick Foundations course. One of the things that they did in V1 is for their server functions, or for their form actions, they call it, you can pass a schema validator as a second argument to validate the form data that comes in. And one of the things I asked was, is it compatible with ZOD4? And they said, well, for V2, we're actually thinking of implementing standard schema so that you could pass any type of valid. You could use ArkType, you could use Valbot, you could use Zod. Because from a meta framework perspective, what do they care? Like what you use,
No,
as a implementation for validation. So I think it's a really, really nice thing that will happen, I hope.
Definitely. It's much better if you leave the choice in the hands of developers.
Awesome. People that have been listening and they're like, this sounds really cool. Do you have some advice for like when should you try to use ArkType? Like obviously one of the use cases is you've got like form validation you want to do, but I bet there's a lot of other use cases you've thought of for when ArkType would be a really good fit.
Yeah, I mean, I think probably one of the more common use cases would be like server payload validation. That's probably the number one use case, especially ArkType. I think is really well suited to that kind of task, because if the things that you're validating are more complex, it's going to do a good job simplifying them down to give really clear error messages, to do that really quickly. And also with ArkType, because of the way the optimization works, you can kind of think of it like there's a little upfront cost to like analyzing the schema and initializing it. But then every time you run validation, it's going to be really fast. So if you think about a form, it's still going to work great for that. So you can use it on the front end, but like, you'll probably only check a form like 1 or 2 times, or what. It's not going to be like something where you validate 1,000 payloads or a million payloads or something with this one instantiation of a schema. Generally speaking, the trade-offs are going to be really, really good on the server side if you can initialize the schema and then use it many times, like, and that optimization will apply every time. So I would say like that's maybe the number one use case. Reading in like JSON files or config files or anything like that you need to validate would also be a really good use case for something like this. ArkType is great at like dealing with complex types and giving clear error messages and being really fast doing it. So I would say the more you're like doing that stuff, it will be good for forms too. But I would say that like if you're just using forms, you're certainly not. I'd say that the difference between ArkType or any other library is going to be less if you're using forms. It still could be great for DX, but like you're not necessarily benefiting as much as you would if you were dealing with a lot more complex types. So I'd say that that's probably one of the biggest like back-end stuff. Validating server payloads, validating like large files you're reading in, config files, whatever that it is, anything like that. And then, of course, like I said, you kind of pay a little bit up front to create that like JIT-optimized validator, but then it's really fast when you run it. And then I'd say also, like, again, if you're kind of interested in doing more like meta level introspection, maybe working on like an ORM or anything like that wants to have more type awareness and wants to be able to compare parts of your model to one another and understand relationships, like that would be a great area where it's not just the like pure validation use case, but it would really be able to like, I've had a few people kind of who are working on some of these more like meta level kind of libraries, and I think like some of the examples where people were really excited were being able to, for example, like tell if one JSON schema definition like implies another is something like a problem they were working on, and they realized since ArkType has like a from JSON schema and can do all those comparisons for them, they could actually just feed that into ArkType and then use ArkType to compare the two JSON schemas and then give you the answer that way. So I'm pitching for more people to use some of these like meta level capabilities as well. So yes, if you're interested in validation, server side stuff, in particular complex types, I think this could really be very beneficial. And also, if you're interested in like comparing types and structures to one another and understanding relationships, ArkType has a lot of functionality for you there as well.
That's excellent. My takeaway is that introspection is one of the awesome features that ArkType excels at. So that sounds
That's
really,
definitely
really
true.
cool.
And I will give one more like little teaser, I guess, for like something that I've been working on for a while for ArkType for 2.2, which is regex types. And this is a little bit outside the scope of like pure ArkType. So it will be part of ArkType's API. Right now, you can define like a regex expression in ArkType, and it will just be inferred as string, because I didn't write a regex parser at a type level yet at that point, but I've been working on that for a couple months. And one of the really exciting things about this is that this is kind of like my idea for bringing type safe syntax to the masses a little bit, because it's not just ArkType. I'm going to publish a package called ArkRegex that's going to be type safe regex that uses all the same parsing principles as ArkType to be really fast, and give you what the shape of any regex you define looks like. It'll give you type level errors the same way ArkType does. If you make a mistake as you're typing the regex, it will give you all the name capture groups, all the index capture groups of any regex you define. And so it has no runtime functionality. So it's only a wrapper around new regex, but you just get all the types from it. So this is something that like in ArkType, it's really powerful also, because you can just integrate those regex types with your existing types. And like a regex is actually a valid definition in ArkType. So like they can talk to each other, and that regex syntax will be directly available. And you could put regex expressions in an index signature and then get a type out that will be like, oh, you wanted like a string starting with foo. All your keys have to look like that and then be mapped to a number. And you can just use a regex to write that. It's kind of like the feature that TypeScript doesn't have, but it'd be really cool if it had. And now ArkType can kind of do it because they're doing the type level parsing. And yeah, you don't even have to use ArkType to get the benefits of like the type safe regex and inference. So it's been a journey for sure, and I've learned a lot about regex that I probably didn't want to know. But I'm really excited to be publishing that soon, and I hope that a lot of people, whether they're using ArkType or some other validator or no validators or whatever they're doing, everyone's using regex. So like a lot of people could benefit from this, and I'm really excited to just get people more familiar with like what the capabilities of that really efficient type level parsing are in TypeScript, and get them more safety for the code they already have, right? You have some like expressions you've written with new regex, you just copy paste what was already there, put it in this, and then you have types associated with it, and it's just really beneficial for everyone. So I'm excited to get that out.
Take my money. I'm excited for that too. That sounds awesome.
Yeah. How do people get started with ArkType? Like, for example, it obviously works on Node.js projects, but are there other runtimes it supports? How do people sort of install it onto their project?
Yeah, so you just use whatever you're using for your package manager, pnpm install, or npm install, yarn install, bun install. What else do people do? I don't know. Anyway, you could use it with all the normal means. So it works with any runtime. The only thing that I know that some people are having issues with React Native and like static Hermes or something. Okay. So I'll say, if you're using React Native, maybe take a look at some of the ArkType issues, give it a try, and hopefully it works fine. It should work fine. All the logic is there, but I do want to support those people. So no shade if you're a React Native developer. I would love, actually, if you want to help me and contribute and help me understand what is going wrong in some of these issues that people have opened to do with React Native. This is an area I really don't know anything about, and I had a horrible time setting up an emulator. So please hit me up, and we can fix whatever issues you're happening with React Native. But outside of that, totally, you can use it anywhere. It's very portable. It's really easy. There's nothing you really have to do, right? You can install the extension in your editor if you want to, but you can see all this stuff if you just go to ArkType.io and you do the little intro, or just look at the getting started page. It'll show you how to install it.
You should definitely go check out the playground, because I feel like that gives you a really great kind of first time experience.
Yeah, you can go to like ArkType.io/playground. That's right there, or just go to the homepage and you'll see a link there. But it works right in your browser, and you can kind of get a full sense of what the local development experience is, which is fun. That's always been a really important point, that you just install it and go. There's no pre-compilation. There's no build step. It will just work out of the box, and the DX, while even better with the extension, should be really good even if you don't have anything else installed. Then you're just using vanilla TypeScript and VS Code. It should be a really good experience there.
So listeners are super excited. I hope they're super excited, because this was a fantastic deep dive. So thank you so much for your time, David. Where can people go to follow you and see what you're up to?
Yeah, so I try to stay pretty active on X and Blue Sky. So you can follow my account, which is SSALBDIVAD, which is my name backwards. It's the name I use everywhere. And also ArkType. And I'm very active on the like ArkType accounts on those platforms, and I'm posting most days. Yeah, check out the website. Is probably a great place to go also, because it has links to everything. So if you go to ArkType.io, or just Google ArkType and you'll find it. Yeah, they've got links to all those like social platforms, including Discord, which you can go to arktype.io/Discord and join our server. It's like getting sort of close to 1,000 people now, so that's exciting. And we'd love to have you as part of that. We're on GitHub, obviously, and you can check out the project there and give us a star if you are so inclined.
Well, thank you so much for your time, David. I think the audience is really going to appreciate this episode. So thanks for joining us.
It was a great time. Thank you guys for having me.
Thank you so much.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to TypeScript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at Kamranigas.com and Eric is at ericonerheim.com. You can also follow the show directly at typescript.fm.